Okay, so now we have all of our servos and our push rods installed on the aircraft, and so let's do our basic radio setup and get it ready to fly. So the first thing we're going to do with our setup is we're going to make sure that all of our surfaces are sub-trimmed to be straight and neutral, and then after that we're going to need to set our control throws. Now, this being a 3D aerobatic aircraft, we want to have 45 degrees of throw. We want 45 degrees up and 45 degrees down on the elevator, and we want 45 degrees right and left on the ailerons. And I'll show you, if you don't have a throw meter handy, here's the easiest way to find 45 degrees. Is just take a regular piece of paper and fold it over like that. And this angle here is 45 degrees. So we'll use that as a throw gauge. And we'll put it right here on the hinge line. And we'll verify that we do have 45 degrees of throw. And we can put it right here on the elevator hinge line and verify that we do indeed have 45 degrees of throw. And we'll also check that on the down throw on the elevator. Now, on the rudder, we won't need to use our throw gauge, because on the rudder we simply want to get the rudder to throw over within a finger's width of the elevator. We want it to stop right there. So if you look right there, there's about a finger's width of distance between the elevator and the rudder. That's proper throw for the rudder. Okay? So there's your throw information, and that's your 3D or high rate throws. Now, you can also set up a low rate throw on the aircraft if you want to. Not very many people are going to use a low rate throw on a 3D foam aircraft, but you can certainly do it. Our recommended starting point for that is take a piece of paper, and instead of folding it all the way over, fold it halfway over, just like that. And this is going to be 22.5 degrees, and you can use your 22.5 degree angle in exactly the same way on the hinge line, and you can set up your low rate throws to be 22.5 degrees on your ailerons and your elevator. We recommend always leaving your rudder on high rate because you'll always need high rate rudder for stall turns, whether you're flying 3D aerobatics or whether you're flying precision. You'll need the rudder to kick the tail around in a stall turn. So there is our setup. Now, if you notice one important thing, since we're doing setup on a workbench here, you'll notice there is no propeller on the airplane. We don't put propellers on electric aircraft when they're on the workbench. We think that this safety tip should be used by everybody. When people get injured by props, a significant number of those injuries happen because they're on the workbench and they're reversing servo directions and they accidentally reverse the throttle channel on an electric airplane, and the airplane comes at them, or it flies into the wall or the china cabinet or something else. So a good tip is do not put propellers on your electric aircraft when you're working on them on the bench. Save the prop until you're outside and you're ready to fly. Now, the only other thing to set up on the aircraft before flight for the control surfaces is we need some exponential in our control setup. And in this case, we're going to recommend that we're 50 to 70% on all of our control surfaces. 60% expo is a good place to start. Exponential is a very personal thing. I prefer to fly at about 60 to 65% on this airplane. Other people are going to prefer different levels of exponential, but you are going to need some exponential in all likelihood to fly the airplane as smoothly and precisely as possible. Okay, so on this EPP aircraft, obviously its crashworthiness is one of its major features, and so we want all the parts of the aircraft to be crashworthy. So we don't want to rigidly bolt a prop onto the motor, because if we hit the ground, we don't want to break the prop every time. So we're using a flexible prop mount where the prop is held onto the motor by an elastic band. Okay, and most of you have seen this before. This is a standard flexible prop mount. If you crash, the prop can tilt out of the way. Okay, and most of these setups use some type of little black rubber O-ring. But in your kit, what you'll find is you'll find a short length of rubber surgical tubing, which is a superior material. And it comes in several different colors. This piece happens to be green, but it can be all different colors. A lot of it is natural tan rubber. And what you do with this is you cut it into 1/4-inch sections and use that to hold the prop onto your brushless motor. And it takes a little bit of practice because it is very strong, but once you get it, this is by far the best way to connect your prop to your brushless motor. It still easily tips out of the way in a crash, but it's much less likely to come loose during flight. So the piece of surgical tubing that we send in the kit, you can cut 4 or 5 of these bands out of it, and this is a better way to do things. So that's how we attach our prop to our Hacker brushless motor on the front of the aircraft, is with the rubber surgical tubing bands. Okay, so we're at the end of our process here. We're about ready to go fly, so I've installed the prop using the green surgical tubing included in the kit, and I've used some hardware store Velcro to attach my live poly. I just put a square of Velcro about 1 inch on the side on the airplane, and I use a little welder's glue for that, because if you do get self-adhesive Velcro to hold your batteries onto your airplanes, you'll notice that the Velcro glue doesn't really stick to EPP very well, so use some welders there. And you don't have to balance the airplane on a CG machine or go into a lot of trouble. The airplane is extremely tolerant of a wide range of CGs. It really doesn't matter for those first few flights. You can just stick your battery right here in the front and go fly. If you want to do a formal CG check, then the recommended range is behind the wing spar, 3/4 of an inch to 1.5 inches behind the wing spar. It's a wide range, and the airplane's very happy anywhere in that range, and then some people may even prefer it outside of that range. It's very much personal preference on this airplane. But if you want to check if you've got a very non-standard power system, just put your fingers about 1 inch or so behind the main wing spar and see if the aircraft will balance, roughly level about 1 inch behind the wing spar. You want it to hang roughly level on your fingers, just like it's doing there. And if it's anywhere around 1 inch or so behind the main wing spar, you're in great shape for your first flight. And so that's it. You're ready for your maiden, and now we'll go over some basic repairs. Okay, so the first type of repair we're going to go over would be a simple tear. So if you do get a tear in the EPP foam, here we have one on the leading edge of a wing. There's nothing missing. We just need to reattach those pieces to each other. You use our welder's glue. We'll just smear some welder's glue. It doesn't take very much. It can be a very lightweight repair. What we want to do is put the edges together and work them back and forth and smear the welder's glue, and then open the crack back up and let it sit open for around 10 seconds or so. And then after it's sat open for 10 or 15 seconds, we put the crack back together, make sure it's all straight. If we want to have a really thorough repair, we can rub a little bit of glue right on the edge that was torn, and it's doubtful that it'll ever tear there again. So let this dry a few minutes, and you can literally be back in the air in just 5 minutes after tearing an airplane by making a repair with welder's glue like this. It's really handy and very quick stuff. Alright, so let's handle a little different repair. Let's handle a repair in which there's actually some foam missing. Now, if you can find a piece of foam that comes out of a little rip like this, you can repair it like you did the simple tear. Just put welders all the way around the periphery of the tear and put the piece back in. You can fix it the same way. But if the foam is missing, then what you're going to want to do is you're going to want to go to your spare piece of foam, which is included in your kit. And what we'll do is we'll take our hobby knife and we'll clean this tear up a little bit to make it a more regular shape with some straight lines, and then we'll cut a patch out of our spare foam. Tear to a more regular shape, and now I'm going to make a patch. I've taken a piece of my spare foam included in your kit, and I'm just going to put it right below the cut. I'm going to carefully, we don't want to cut our fingers, I'm going to carefully cut a patch the same size and shape. patch fits into the tear. Okay. We'll use our welder glue again. We'll spread some welder glue on the foam patch. We'll insert the patch into the tear and we'll spread the glue around. We'll pull it back out. Let it dry 10 or 15 seconds. If you didn't get good enough coverage, put a little more welder glue on the edge of the patch, let it dry for a few seconds, and then you can apply the patch and let it dry for a few minutes. And once the glue on the patch is dry, you can just take our hobby knife and we can trim the patch, and it's not even really very visible. You can do this a lot of times with this aircraft. You can repair it in all sorts of ways.